Okay, section 2.5 is talking about implicit differentiation. First of all, we better talk about what implicit and explicit is, the difference. What we have been doing is explicit, where basically they clearly state what y equals. So everything we've been doing is either y equals something or f of x equals something. So all we have to do is we have to plug in an x and we figure out a y. That's explicit form. Implicit form is maybe we have x and y's on the same side. Maybe they're all tied together. Anyway, kind of like this here. Both x and y are on the same side. It's not explicitly clear on what y equals if we plug in some x. All right, so if I plug in 3 for x, I actually have to do a little bit of algebra to find out what y is. And that's why I have to divide and get 1/3. So that's the difference between implicit and explicit form. What we're going to look at now is taking the derivative of something in implicit form, because sometimes it's just way easier other than multiplying a whole bunch of stuff out, factoring a y, and solving for y. And anyway, it's just much easier, all right, to find the derivative implicitly. So one thing where implicit differentiation comes from is the chain rule. All right, when we've been taking the derivative, all right, so down here it says find d dx of y cubed. What this d means is find the derivative with respect to x. So if you notice in all the equations, we've been finding the derivative of x. Well, now we have a y, so how do we do that? Well, we have to do the chain rule, all right? What we do in the chain rule is we take the derivative of our y, so it's 3y squared, all right? And then the derivative says, well, we need to multiply, the chain rule says we need to multiply by the derivative with respect to x. So it's some change of x like that. All right, and that's all it is. I mean, it seems harder, and I have a video from Sal that explains it more in detail of why that works. All right, but to take the derivative with respect to x for implicit differentiation, we just take the derivative of our y like we regularly would take a derivative. We bring down our power, we subtract it by 1, and then we take it times dy dx. All right, because technically we're taking it with respect to x, so we have to do the chain rule. So the chain rule says we actually have to do this one, and we have to do the derivative with respect to x. So it's the derivative with respect to x and the derivative of y. All right, I hope that makes a little bit of sense. Really, implicit differentiation isn't really too hard once you get past the fact that this is all you do. You take the derivative with respect to y, and you multiply it by dy dx. All right, so looking at b here, we look at b. All right, we take the derivative with respect to x. Well, okay, so we're going to take the derivative with respect to x of x and the derivative with respect to x of 3y. We can do these separately. We can just take the derivative like we normally do. Since this is just an x, we don't have to change anything. We're taking the derivative with respect to x. This term has an x. So we just take the derivative. The derivative of x is 1. Okay? Now, this, we're taking the derivative with respect to x. We don't have an x. So we need to do implicit differentiation. So or not really implicit differentiation. We're going to take the derivative using the chain rule. So we take the derivative of just our y, which is 3. We have to multiply it with respect to our x, since there's no x in there. All right? So that's all that derivative is. So you just take the derivative of 3y normally and add a dy dx is what it boils down to. All right? Looking at the last one, C, we have two things multiplied by each other, which would tell us that we need to do the product rule. All right, so I'm going to do the product rule. I'm going to take the derivative of the first one, the first term. My first term is x. So my derivative of x is just 1 times y squared. And that's all I have to do because I took the derivative I took a derivative of x. So I don't need to add my dy dx because I took a derivative of an x. In my second term, however, though, I'm going to leave my first term and take the derivative of my second term because that's how the product rule works. The derivative of my second term, well, this is we're taking with the derivative with respect to x. All right. So we have to do the chain rule. We have to say that the derivative of y squared is 2y dy dx. And that's all we do. We're left over with just saying, okay, we have y squared plus 2xy dy dx. And that's it. All right. Moving on, I have few guidelines here to solve for our dy dx. So when we take implicit differentiation, it doesn't change what we're doing. When we take the derivative, we're still finding the instantaneous velocity. We're still finding the slope of the tangent line of this some shape or curve that they gave us, this equation. All right. So what we do is we differentiate both sides of the equation with respect to x. So both of them with respect to x. We collect all terms involving a dy dx. So if we took a derivative that involved a y, we want it on the left side. If it doesn't involve a y, we put it on the right side. We're going to factor out dy dx, and then we're going to divide by the remaining parts. And you'll see how it works here in a little bit. Okay? And this will make more sense here in a little bit. Well, example 2. Find dy dx, given that y cubed equal, that equation right there. So we want to take, our guideline said, take the derivative with respect to x of both sides. So I'm going to take the derivative with respect to x of both sides. All right. I should have had, sorry, d dx. I'm going to take it with respect to x. All right. Well, when I take it with respect to x, I had to do the chain rule. So it's 3y squared dy dx because I'm taking a derivative of a y with respect to x, plus, again, 2y dy dx minus 5 dy dx. I'm just taking the derivative of the y, adding my dy dx is what it boils down to. All right, I hate saying that, but that's the easiest way for you to be able to do it, to understand it. Understand that we're doing the chain rule when you have to take the derivative of y and take it times the derivative of y with respect to x, and that's where my dy dx comes from. And then my last term here is an x squared. Derivative of x squared is in terms of x already, so it's just 2x equals, now when I take a constant, excuse me, when I take a derivative of a constant, it's just always, no matter what you're taking respect to, derivative of constant is going to be 0. All right, our guidelines now said, okay, take everything that involves a dy dx, every term that has a dy dx in it, and leave it on the left side. Take anything that doesn't and put it on the right side. So what I have left over is 3y squared dy dx plus 2y dy dx minus 5 dy dx equals to 2x. And then it said factor out a dy dx. So I'm running out of room here. I'm going to factor out a dy dx, which just leaves me with 3y squared plus 2y minus 5 equals 2x. And to solve for dy dx, because that's what we want to solve for, we want to get dy dx by itself, okay, we're just going to divide this over here to get dy dx by itself. So dy dx equals 2x over 3y squared plus 2y minus 5. And that's our answer. Okay. Our next one. Find the slope of the line tangent to the graph of x squared plus 4y squared equal to 4 at that point. Well, it doesn't change. All right, this is what we did earlier. We just needed an x value when we were in explicit form. When we're in implicit form, we need the y value as well. All right. If you notice, if we wanted to solve for y and do it explicitly, we'd have to bring an x squared over, divide by 4, and then take the square root of everything, and then try to take the derivative of something underneath the square root. And we'd have a messy chain rule. Well, this way we can just do implicitly. All right, so I'm going to take the derivative because that's how you find the slope of a tangent line. You take the derivative, all right, of this function right here. So when I take, I'm going to take d dx of that entire function, x squared plus 4y squared equal to 4. And then when we're done, I'm just going to plug my point in and I'm going to get my slope. All right. Okay, so when I take x squared, the derivative with respect to x, I have an x, so I can just take the derivative. All right. Now when I take it 4y squared with respect to x, I got to actually take the derivative of y and then multiply it by the derivative with respect to x. So when I take the derivative of y, I get 8y, and take it times the derivative with respect to x, dy dx, equal to, now a constant. The derivative of a constant is always 0. All right, our guidelines told us then to get dy dx by itself. All right. Sorry, this should be an 8y. Okay. Divide by an 8y to get my dy dx by itself. And when we divide by an 8y, it's going to cancel out. It's going to become a 4. So I have a negative x all over 4. And they want us to find the slope, so we're just going to plug this in. All right, so I'm going to plug the square root of 2 in for x. And I'm going to plug a negative 1 over square root of 2 in for y. All right, well, this is just dividing fractions. Negative square root of 2 divided by 1 all over the square root of 2, actually negative. So I'm going to multiply. I'm going to save this. I'm going to flip this. Flip the sign, or change the sign, and I'm going to flip this. Excuse me, got a little cough. All right, so I have negative square root of 2, change the sign times the square root of 2 all over 1. Or where did I mess up there? Sorry, this is a 4y. That's where I messed up. This should be multiplied by 4. Sorry about that, so it should be over 4. There we go. Okay, so when I multiply a negative and negative, it's going to make a positive. Square root of 2 times the square root of 2 is just 2. And then 4 times 1 is 4. So I'm left over with just a positive. 1/2 is my slope. Sorry about this. I forgot to bring my y over. All right. So it should have been negative 2x over 8y. Cancels out to be a 4y. So when I plugged my negative 1 over square root of 2 in, I should have had a 4. I've been multiplying it by 4. All right. There's the bell, and this next example takes a little longer, so I am going to make another video later, and you can check that one out as well. We'll see you in the next video.